EACC Math Lesson number 25, the Pythagorean Theorem. Pythagoras was an early Greek mathematician, philosopher, teacher, and he's did a lot of things, but he's best known for his proof of this theorem, and thus it became the Pythagorean Theorem. What he saw was that in every right triangle, if you made squares out of all the sides and you looked at the areas of these squares, the area of the two smaller squares always equaled the area of the larger square. So we know it by this formula here. The square of the two legs is equal to the hypotenuse squared. And the hypotenuse is always opposite the right angle, and the legs always make up the right angle. And you usually see it written a squared plus b squared equals c squared. Okay, our first problem, here we have a basic right triangle. We have the two legs. We're looking for the hypotenuse. So I know that the sum of the squares of the two legs is equal to the hypotenuse squared. So 9 plus 16 equals c squared, so 25 is equal to c squared. So once we get to this point, we take the square root of each side. So I've got the square root of c squared, which is c, is equal to the square root of 25, which is 5. So our missing hypotenuse has length 5. This is called a Pythagorean triple. It shows up a lot, 3, 4, 5. Okay, in our next example, here we have one leg. We're missing the second leg, and we have the hypotenuse. So, setting it up correctly, I know that the sum of the squares of the two legs, so 24 squared plus x squared, is equal to the hypotenuse squared. 24 squared is 576 plus x squared is equal to 676, 26 squared. Subtract 576 from each side, so x squared is equal to 100. Take the square root of each side, then I know that x is equal to 10. So my missing leg would have length 10 units. With this example, here we have one leg, we're missing a leg, and we have the hypotenuse. So again, our setup is 10 squared plus x squared is equal to 17 squared. So 100 plus x squared is equal to 289. Subtract 100 from each side, so x squared is equal to 189. Take the square root of each side, so I end up with x is equal to the square root of 189. Now, why did I write 6 there? 189. Okay, 189 is not a perfect square, so let's, in this case, we don't really need an approximation. Let's simplify 189. I know that 189 is 9 times 21, and the square root of 9 is 3, and we'll just leave the square root of 21 alone then. So my final answer is 3 square roots of 21. All right, in this example, here we have a layout of a golf course, and you can play or get to the green in 2 shots here, making a 120-yard shot here to where the right angle is, and then a 70-yard shot to the green. Or, if you think you're good enough, you could hit straight from the tee over the trees to the green. Well, it would be nice to know how long that distance is to know what club you need to use. So, I see we have a nice right triangle. And again, using our Pythagorean theorem, I know that 120 squared plus 70 squared will give me my hypotenuse, or we'll just call it good old x squared. So 120 squared is 14,400 plus 70 squared, which is 4,900. equals x squared. So 19,300 is equal to x squared. So taking the square root of each side, we get x is equal to, now, 19,300 is not a perfect square. So again, I could look to simplify that, put it in simplified radical form, but in this case, I really would like to know about what that distance is. So I'm going to use a calculator and then round off my answer, and it's about 139. So I'll use these squiggly lines saying it's just about 139. And golf measurements are usually given in yards, so I'm going to say I've got about a 139-yard shot. Okay. Next example, here we have a ladder 39 feet long leaning against a building. So let's sort of depict what's going on here. So I've got a building here and a ladder that's 39 feet long. It's leaning against the ledge of the window. If the foot of the ladder is 15 feet from the base of the building, so I know this dimension down here is 15 feet, how far is the window ledge above the ground? So we're looking for this dimension here. Well, again, we can use our Pythagorean Theorem, so I know that x squared plus 15 squared is equal to 39 squared. So x squared plus 225 is equal to 1521. Subtracting 225 from each side, I have x squared is equal to 1296. And taking the square root of each side, 1296 happens to be a perfect square, and the square root of 1296 is 36. And since our measurements were in feet, I'm going to say that window ledge is 36 feet above the ground. Another example, Mindy and Christine started from the same point. Christine traveled west. Okay, so let's say they're starting from this point right here. Christine traveled west at a rate of 30 miles per hour. Mindy traveled south at a rate of 40 miles per hour. How far apart were they after 1 hour? So we're looking for this distance right here. Well, we're going to assume this is a right angle here, so we have a right triangle. And again, I'm just going to call our unknown side x. So after 1 hour, she's gone 30 miles. She's gone 40 miles, so I know that 30 squared plus 40 squared is equal to my x squared. So 900 plus 1600 is equal to x squared. So 2500 is equal to x squared. Taking the square root of each side, I have x is equal to 50, and our units are in miles. So they're 50 miles apart at the end of 1 hour. Okay, you've got some problems in front of you. Go ahead and work on them. If you have questions, please let me know. And I know some of you feel this way. Math is mental abuse to humans. Ha. See ya.